Okay, so we're moving on from this redox chemistry to concentration of solutions. And specifically, molarity is what we're going to be using to calculate the concentration of solutions. And this is going to be our last topic before our upcoming exam. So what's the big deal with molarity? Well, like the poison rats, I guess that was meant to be, though, right? So you'd want that concentration to be high enough to kill those rats. So in that sense, that's how molarity would be important. But it's very useful. It's what we're going to be talking about today. Molarity. What is the difference, would you say, Lorena, between a solute and a solvent? What's the difference? One of them's a particle, the other one's a... Kenneth, you got an idea?
Is a solute something that can dissolve and a solvent something that dissolves?
So a solute needs to dissolve, right? If it doesn't dissolve, it's going to lay on the bottom, and that's not going to be much of a solution, right? You want it to be the same throughout. You want it to be homogeneous. So a solute definitely better dissolve in the solvent. Does the solute have to be a solid? Aren't we used to thinking of that? It doesn't have to be, right? You could dissolve beer in the ocean. So beer is your solute, the ocean is the solvent. So the idea is that you're mixing two things. The one that you have the most of, doesn't matter if it's a gas, a liquid, or a solid, because you can have solutions of gas, liquids, and solids. If you have a mixture of two things, the one that you have the most of is the solvent or the solute. Solvent. This is the one you have the most of. That's all there is to solutions. Is you pick the component that you have the most of. Boom, that's what you call the solvent. Okay. Molarity, Dylan, which we're going to be spending today on, is used to describe the blank of a solution. The concentration, right? Exactly. Molarity has units of big M, Lauren. How do you, so we're not supposed to say, and I'm not supposed to say, 0.21 big M sodium chloride. I'm supposed to say 0.21 what? Sodium chloride. Molarity, sodium chloride, that will work, but that's not what they want. The convention isn't molarity, it's molar. Stop at the molar. But I wouldn't argue with molarity. 0.21 molarity sodium chloride, it works for me too. But molar is the way you're supposed to go. Molarity is not moles of solute, nor is it liters of solution. We need an equation for molarity, Stephanie. What equation can we use to calculate molarity? Okay, solute. Okay, we're close. Solute all over solution. Now that's part of it, but those aren't units though. What units for solute? She's right though, Kenneth. What of solute and what of solution? It's not going to be grams of solute. They want moles. They want moles of solute. So plug in the number of moles of solute. Divide that by the what of the solution, Emily. It's not grams of the solution. It's not milliliters of the solution. It's, does anyone know? Liters, big L. Liters of solution. Do you remember how many milliliters, Bowdy, were in a liter? Yeah, how many milliliters were in a liter? 1,000. Just seeing if you guys remember that, right? Okay. So you divide the number of moles by the number of liters, and then you get your number for molarity. Connor, let's just make sure we understand our algebra here. How would you solve this equation for liters, right? Because this equation has 3 variables in it. They're always going to give you 2, and they're going to say, what's the liters of the solution? They'll give you molar, and they'll give you moles of solute. How do you solve for liters of solution?
L equals moles of solute over molarity.
There he goes. Do you guys agree? All he did, right, you recognize what's on top and bottom? And just switched them. He's right. So the number of liters, he said, number of moles of the solute all over the, what do we say, molarity. All right. So be able to manipulate that equation, that definition. So we take a solution, and these solutions, we can dilute them. How can you dilute a solution, Ashley? How can you dilute a solution? Going to dilute the solution. You like coffee in the morning. You're going to dilute it because it's too strong. My mother-in-law who lives with us, she has to do that. What would she add? She's going to dilute it. She never says the word dilute it. It's just too strong. So she just adds water, right? Because water is the solvent. So how would you dilute something? Just add more solvent. So you really can't say add more water, because what if the solvent isn't water, right? So just add more solvent. When solving dilution, so this is going to, so we really have 2 homework problems. One is calculating molarity of a solution. So they'll probably tell you grams, so you got to convert it to moles. And they'll probably tell you a milliliter, so you got to convert it to liters, and you divide the 2 and you get molarity. That's probably going to be one problem. But then here's another one. They're going to give you a molarity of a solution, and they're going to dump some water in there, or some solvent. What's the new concentration? So we need an equation to do this. But the background for this equation is that what doesn't change is you're only adding solvent. You're not adding what, Mia? To this solution. We're only adding solvent. We're not adding any solute. No solute is added. So that means the amount of solute doesn't change. So it leads me back to the question of my mother-in-law, right? She pours water in her coffee, but she still drinks the whole thing. So the point is she's trying to reduce the amount of caffeine. Well, she's getting the same dose of caffeine, right? You just got to drink less. So she's drinking the same amount. You see what I mean? So it's kind of odd. But you don't touch those things. So what equation is used for all dilution problems? Oh, let's see if Kendall got this out of the reading. There was an equation. It had 4 variables in it. Did anyone see it? Big MV equals big MV. Then they had subscripts on it. Initials and finals. Okay. So, Mia, if we're going to use this equation, we better know what the variables are, right? First, there's how many variables in this equation? How many variables do you count in that equation? 4, right? So that means in every homework question, Giselle, they're going to give you how many? If they give you 4, there wouldn't be anything to do. They're going to give you 3, and then you got to solve for the 4th one. That's how it's always going to be like that. Okay? So, and that sounds fine, Manuel, but we better know what the heck these variables are. What do you think the big M's stand for? Remember, this is a dilution problem. Molarity, exactly. So here's your initial molarity. MF, everybody, would be your final molarity. Okay. And our units, Audrey, for molarity are what again? What? Yeah, molar, big M, right? So that's fine. So those big M units are going to cancel. That's no problem. The V's, Paul, are probably what? What are the V's? Probably what? Remember, it's a dilution problem. We're going to start out with some initial V, end up with some final V. It's probably you're dumping in a lot of solvent. What's changing? The volume. The volume. The volume's changing. So you've got initial volume and final volume. Okay, now let me save you a little bit of trouble here. When we're talking about units, Lorena, big V's, what were the units for big M again? Yeah, molarity or molar, but it was moles over liters. So do the V's have to be liters? You would think so, right? It makes the most sense if your V's are liters. But notice how the units cancel. So if they give you the problem in milliliters, right? If they give you the problem in milliliters, the milliliters are going to cancel too. So you don't have to work in liters if you don't want to. Because they almost always want their answers. When you're solving for a V, they almost always want it in milliliters. Because no one ever measures liters of anything, right? Everything is these little graduated cylinders of milliliters. Okay, so if you want to save yourself a little bit of time, you can just leave volume in milliliters, and you'll have the same. It'll work. Okay. Went to Sam's. Bought an entire year's supply of blue vitamins in a single bottle. Here it is. Every morning. So you know, Sam's, you buy bulk, right? So why buy all these little solutions of vitamins when you can just buy the great big thing for a fraction of the price? But you got to go through the work of diluting it every morning. So every morning you need a dose of this stuff. You need 100 mils of 0.59 molar blue. Now the stuff you bought was 11.7 molar blue. Right? So you want to make this solution from that, right? From that concentrated stuff. So how would you prepare it? So first, Dylan, let me ask you here. I see us having two equations. There's one equation. Here's the other equation. More than likely, to answer this question, which one are we going to be using to solve it? First one? It gives you the milliliters. But which big M would you use? The initial? So, whoa. Use the other. This is, to me, this is really confusing. And if you just don't read it too carefully, all you do is, if you see this, the dilution problem has 4 variables in it. It has how many big M's? 2. It has how many volumes? 2. 2, right? So if you ever see a problem with 2 molarities or 2 volumes in it, it's going to be a dilution problem without even reading it. If you only have, one of each, it's going to be a, see the difference? So that's how my brain works on these. Otherwise, you could do it Dylan's way, but it's going to be a job. It's going to be a real job to get there. Okay. So this is the equation that they're talking about. Okay. So that means that Mi, Vi, Mf, Vf. One equation, 4 variables, Lauren. They gave us 3 of them. We have to solve for the 4th one. Do you see one of these variables and what number I can plug in for it? Mi, Vi, Mf, or Vf? VI is, well, VF would be 100. That's key to see. You see, that's where you want to end up. So that's really important to see. Stephanie, you see why VF is 100 milliliters? Yeah, VF is, that's where they want to end up. Kenneth, another variable.
MF would be 0.59.
Yes, MF would be 0.59 molar. We need another one. Emily. MI is 11.7. So that's how you pick these numbers out. We have to solve for VI. So let's do that. Now I'm just going to leave things in milliliters. Why not? MI 11.7. VI equals MF 0.59 molar. VF 100 milliliters. All right. So, Bowdy, you see how to solve for VI? What would you do to solve for VI? Yeah, divide by the 11.7. Multiply the 0.59 times 100. Divide by 11.7. And I remember my answer. I just did this. 5.04 milliliters. Right? But I'm getting old. My memory may have failed me. Did it? Oh, it is? Okay. So 5.04 milliliters. But this is a favorite thing of the homework. Favorite, I'm telling you. How would you prepare? You can't just draw a box around this and go on to the next problem. You're going to lose a lot of points. You got to say, how would you prepare it? So let me give you a little hint here. This is how I do these. This is my answer for how would you prepare. Take VI of MI and dilute to VF to get MF. That's my how would you prepare. Now, my variables, I can't leave them in there. I got to cross them out and put in the real answers here. So instead of saying take VI, whoop, let's change, make something you can see here. VI is 5 mils. Take 5 mils of MI. Well, MI was 11.7 molar. And dilute to VF, well, VF is 100 mils, to get MF, well, that's 0.59 molar. Okay, so those are my directions. Take 5.04 mils. Well, I can't get the 0.04, so that's why I just wrote 5. So take 5 mils. Here's my 11.7 molar. Take 5 mils. So suck some up. What is this doohickey called? Graduated cylinder. Yeah, so I need 5 mils of it. All right. Nailed it. Okay. There's my 5 mils of it. Then I need to dump it where? In a flask that says what on it? That says 100 mils. So these are called volumetric flasks. So this is the part where we dilute to 100 mils to get the 0.59 molar. So this dilute to 100 mils, it's a lot easier to use a flask with the mark that's built for it. So otherwise you'd have to, it wouldn't be very easy, right, to dilute to 100 mils because you have this volume to worry about. Then you got to be careful dumping in the solvent. You know, when would you stop? It's so much easier just doing it this way. Okay, dump that in there. Probably rinse this out a little bit so I can get it all. Okay, and I just got to get it up to the mark. The mark is way up here. There's a mark. it goes. There. Put a little cap on. And somebody did a study saying you got to invert this thing 12 times for it to be totally mixed. Whatever, right? So there. There is my, I took 5 mils of 11.7 molar. I diluted it to 100 mils. I have 0.59 molar. Woo! So this is what I'd have to down in the morning, right? They must have wanted all the water because it's bad for your stomach or something. Okay. Let's solve this one together before we go to the boards here. We have 48 grams of sodium chloride. It's dissolved in 250 mils of water. Oh, you know what we should do? Let's do this. Let's look at each one of these problems. And I'm going to ask you which equation are you supposed to use. Then we'll just go to the boards. That'd be better, I think. Okay? Because once you know where to start, I don't think it's so bad. So Connor, here's this first one. I've got 2 equations I can write here. Which equation would I write to solve this problem? The molarity equation. Big M was what over what?
Moles of solid.
Moles over
liters.
liters. You can write moles of solute if you want, but so I think you're the one who's going to have to be writing this expression. You're going to have to know this. Right? He's right. Because the units are just messed up, right? You're going to have to convert, everybody convert this to moles. Convert this to liters. Saying that, this is going to be awesome. You guys are going to ace this quiz. Ashley, how about EX2? Which equation? She was really quick on it, right? Because she's looking at it. She doesn't see 2 big M's. She doesn't see 2 volumes. Molarity. How about EX3? Tanya. Molarity again. EX4. Part A. Kendall, part A. The big M? Everybody agree? All right. To me, that's my hint. That's my hint. So it's going to be a lot easier. Okay. Then to describe the steps. How about 5? Oh my goodness. Mia, what do you think about 5? Yeah, I think this last part but you have to calculate. You see how this question is going to involve both of them? Because the first sentence, you have to calculate what MI is. And you have to use what equation, Giselle, to get it? The molarity equation. So this one is ugly, right? In fact, we should probably just start doing this one. Make our life, come on. Right? Big M. Moles over liters. To get MI. Okay? Alrighty. Oh, there's one more down here. How about EX6? Manuel, any ideas on how to solve EX6? You're going to have to use both again. Very well. Very good. Well said. You're going to have to use both. This is another one of those you got to use both. Make sure you can see that. Is anybody lost on that? No? Okay. So, should we just start with a hard one, or you want to break into this easy? Let's do the experiment. Let's see if you guys can do EX6. All right, let's try it. Then we can jump around. Let's try EX6. Now, this is kind of long, so if you don't want to go to the boards, fine. I'm not going to force you, because it's a two-part problem. But I think it's more beneficial to everybody, but whatever. It's a Friday, and I know you guys are lazy. Look at Ari, doesn't even want to move. So try EX6. And Manuel's right. This is going to be a two-part problem. Yeah, let's try EX6 here. This is, I think, the toughest problem that you're going to face. Did you get your MI? I got it to be 0.77, but I might have done something wrong. Did you get 0.77?
Yeah, well, yes.
Okay. Okay, yeah, it should be 0.769 would be better. Yeah, just finish your sentence and dilute. Yeah, that's right. Compare your answers with the folks around you and make sure you write your sentence, because how would you prepare? And if you guys agree, just go on to the next one, EX7. If you're not sure how I got it, now's the time to be asking. If you got it, try EX7.
Is the sentence always going to be enough format?
It can be whatever sentence you want to make. But it's just easiest for me to answer the question this way, because I can remember, take VI of MI, dilute to VF to get MF.
Oh.
So it's the most concise, quick answer, because exams are timed, quizzes are timed, and it's just easier than to write a big story.
Since this is an obviously
That has to be in moles. Is anyone stuck on EX6? Let me help you. EX7. Try EX7. Do you may get an answer for EX7? No? Hopefully you're using this expression, right? Because I don't see two volumes in here. I don't see two molarities. And they're asking for volume, so that kind of gives you a big hint what variable to solve for. Mm-hmm. Mm-hmm. It should be. What's the molar mass of sulfuric acid? 98.9. Thank you, sir. Oh, they want the answer in milliliters, though. Did you get 45 mils for number 7? You okay with that? Lorraine, you got it? All right. We haven't done an easy one. Let's just do an easy one, then we'll let you go. Right? Because this is where people usually screw up, I think. Right? Let's just do this one. Do EX3, then we'll call it a day. Do EX3, then we'll call it a day. How many grams of sodium chloride should be added to 100 mils of water to prepare a solution of 0.85 molar sodium chloride? Did you get 0.085 moles? All right. But then you got to convert it to grams. Right. So get those 0.085 moles. All right. Solve for moles. Get those 0.085 moles. Then convert them to grams. Then you'll have it. So this has to come up top. It's going to be 0.85 times 0.1. Times 0.1, because this has to go to the top, right? That diagonal story, and it has to go up to the top. I've got 58.6 0.43 grams in a mole. About 4.97. All right. Okay, so have a good weekend.